Welcome back to the hyperbolic heaping chamber. We are back once again. Today we've got the tie-dye sauropod drip on, which is the same exact thing we were wearing yesterday, I believe, but this is simply a casualty of the crime. So this is kind of where we're at. Fortunately, we almost missed. I said fortunately. Also, fortunately indeed, we almost missed yesterday and we were freed. But no, I'm joking. We actually weren't close to missing the session actually, but we were close to not uploading it, which I made a mistake. But fortunately, we had a comment from the top algorist on the eastern seaboard. The Control C Ninja struck again, saving us from forgetting to upload. So if you check yesterday's video in the timestamps, when LeetCode usually shows that when you submit a problem. I think I did it at like 2 or 3, but the video was uploaded at like 3 a.m. And yeah, I forgot to upload it. I upload so many times that I literally just forget to. I thought I had already been done, and so that being the case, thank you God King. We were saved by the legendary algorithm. So feel strong, man. This is part of the benefits of the hyperbolic coding chamber. We truly are La Familia. So imagine Hitman Reborn. We are the Vongola tribe. So if you're interested in something like that, you should definitely join the hyperbolic coding chamber, because also we have lots of secret tips, cheat codes, and goofs and gaffs that might be applicable for your interview. So you have also the top CS related or LeetCode related puns and jokes that you can crack during your interview. That also proven, because we have some data analysts, to increase your interview acceptance rate by 10 to 15%. So you're going to want those goofs and gaffs for quick disposal if that's something you're interested in. But where we are currently at, there's not much else to say. For some reason, we seem to have hit the stride with the consistency here, and it's just time to put in the hours. So I think this past week we spent like 30. We did like half of the week was an hour and half of the week was 30 minutes. I think there was just a lot going on at work. I think, and my sleep was trash, so we just kind of fell off the wagon there a bit. But I don't think it's falling off the wagon. I think we also have to be willing to shift the lines when we need them. So that has been pretty good. So I also just read for about 4 hours, and that was pretty rewarding. So maybe it takes a step at a time. So that's currently where we're at. So I think we're kind of beasting through these easy problems, and I kind of want to already get to the medium problems already, so we don't get stuck in Elo hell. But I think we have, if we check the LC charts, I think we have 301 problems done, which is actually, we're not even close to half of all the easies done. So we have a long way to go, but we're about a little less than halfway through, and I honestly do believe in 2 months we'll have finished all the easies. But we have to keep up with the hour game plan, and hopefully we won't have to take any more detours to do any explore cards. But I would really like that goal to happen. So that being the case, we're locking in for a classic hour today. And I'm feeling pretty hyped about that. So hopefully we can slay a lot of problems. And it's also a little bit more fun because we're able to solve more problems, but also less fun because part of the fun is challenging. When the problem is challenging, you have to like look through the maze and try this and that and try to reframe problems. But it's been interesting. It reminds me of the book Moonwalking with Einstein, and how pretty much making visualizations is key to memory and stuff like that. And so when I do these problems, a lot of the times I'll try to do them without looking at the example, because I want to encode the problem as some kind of weird visualization in my head, and then I'll try and solve it. Fortunately, that helps somehow. I'm not really exerting how, but if you're interested in more information about that, Moonwalking with Einstein book has more information about that. So that is currently where we're at. Hopefully we can do an hour today. I think we will, and hopefully we can solve a lot of problems as well. I'm feeling a smoothness. I'm feeling a smoothness in our ability to cook today, but I'm also feeling a slight bit of tension in the brain waves. I think I do better on LeetCode when I'm a little more relaxed. So we can more creatively see the problems, but I feel more focused today, maybe too focused. So I think there's also like a bit of relaxing that is better. So yeah, and I think I always reference a book, but I think there was a book that had a study about I mean, I think we already know this intuitively, but students perform better on tests when they're more relaxed, and one way to get more relaxed is to study more. So I'm definitely feeling less relaxed, so I'm not exactly feeling that in our prime form, but it's better than nothing. So I think that's where we're at today. We're going to lock in for the hour and start the cooking. Also, shout out to everyone in the Hyperbolic Coding Chamber, as well as the Copy Ninja and friends. So where I think we could do design hash set. Let me see if we have. Looks like we got some crazy problems today. Apparently I exceeded the rate limit. Let's try design hash set. So we're trying to design a hash set without using any built-in hash table libraries. Implement the myHashSet class. Void add key inserts the value key into the hash set. Bool contains key returns whether the value key exists in the hash set or not. Void remove key removes the value key in the hash set. If key does not exist in the hash set, do nothing. So I think this definitely depends on the things being added, but if we're going to use key, if we're going to use numbers as what we're primarily going to be adding, then we could just use the bucket formula, where we'll have 10 buckets, an array of 10 buckets, or I think it was, I don't know where I got this from, but I think it was proven that 1000 was the best number of buckets. But we could have 1000 buckets, and at 1000 buckets, right, we'd take a number like 100, right, and we would mod it by 1000, and you should get 0, I think. Oh no, you get 1,000. No, yeah, it's less than 1,000, so you get 100, right? And then we pretty much take all these numbers, right, and always do it mod 1000, and this would always give us a bucket in the range between 0 to the bucket size, right? Then to find a value, the way that we do the collision resolution would be based on if each bucket would be an array of elements itself, and then we could do a linear time search to find the element. And I think based on the number of buckets, it should average out to I don't think we're gonna get constant time, but it would be linear space. Yeah, the speed would be questionable. I mean, it would be pretty quick. It should average out to constant time amortized, but maybe not. But I'm thinking what we could do is we would have our buckets, which would just be an array of arrays that would start with no it would be empty. We would have a size, which we could just say to just be a constant called max buckets, and then for let I is equal to 0, I is less than max buckets, we do I plus plus, and we would say that buckets dot push onto it an array. Right, if we push on that array, right, we should get on every run 1000 arrays created within this array that should be empty. To add an element, right, we want to insert the value key into the hash set. So to do that, we need to get its bucket. We can get its bucket by doing key mod this dot max buckets. Oh wait, our IntelliSense is working again for some reason. Right, this is the bucket that it should go in. Right, and then we can say this dot bucket sub bucket dot push key. right? To remove a key, right, we need to figure out what bucket it is that key is in. So the modulus lets us map each key to the bucket it's supposed to go in, but also when we want to remove a key, we can also figure out the bucket it exists in. The only problem that could be an issue with this is that when we remove an element from the inner array of arrays, this technically kicks off a linear time shifting process in the array. So if we had access to something like a deck, it might be better to do an array of decks instead, so that we could remove an element from the bucket in constant time. But we could just make a note of that. But maybe that's what I'm thinking. Const bucket equals key this dot max underscore buckets. Right, and then we have to search, right? So we could say for let I is equal to 0 I is less than this dot bucket sub bucket dot length. I plus plus, right? And then if we want to say if right, this dot bucket sub I equals key, then we can just remove that index. So we'll say this dot bucket sub I. Oh no, we'll take the array, right? And then we'll splice, which will give us our start index, right? We want to delete one element. And then for contains, we can do the same thing here, except instead of deleting, we'll just return true. Otherwise, we'll return false. So we add 1, we add 2, contains 1, true, contains 3, false, add 2, all right, contains 2, true, remove 2, oh my god, there should only be 1. I forgot. Inserts the value key. Oh wait, this is not a wait. I thought I was building something else. I thought I was just building a dictionary. This is a hash set. Not using any built-in hash table libraries. So instead of having an array of arrays, can we just have an array of sets? Wait. Or is a hash set the same thing as a set? I don't understand. Or is a hash set actually a set? If that's the case, then maybe we can just do add the key. Well, I guess to fix it, we could just check. All of these operations would be so slow. I guess, is there a way to know if we already have the key or not? We can just say if the bucket sub I ever equals the key, right, we'll just return. And then if it doesn't ever find it right, we'll just add it. We'll just say bucket sub bucket dot push key. Maybe this makes sense. Seems pretty slow. It says 97%, but I can't see the difference between this and a hash map though. Oh, we're mapping a key to a value. Here we're just mapping. I see. What if we try a smaller amount of buckets? It should be much slower. Okay, it's not much slower. Maybe 10 is the ideal bucket number. Yeah, I'm not really exactly certain where to go from here. $769. Okay. Is the base modulo. Oh, okay, they did the same thing with exists. Okay. Alright. Okay, so we actually got that right. But we didn't use the right number of buckets, which seems that it should be 769. So I think we will take that one and try calculate digit sum of a string. You are given a string s consisting of digits and an integer k. A round can be completed if the length of s is greater than k. Divide s into consecutive groups of size k such that the first k... Okay. A round can be completed if the length of s is greater than k. So k is the min length to perform a round. Divide s into consecutive groups of size k. Divide s into consecutive groups of size k such that the first k characters are in the first group, the next k characters in the second group, and so on. Know that the size of the last group can be smaller than k. Replace each group. So we have okay. It looks like we just have to do while s it looks like we just have to break them up into groups of size k, and then we sum together the pieces. To break them up into groups of size k, we could just say ten, 1, 2, 3, so I think we could we'll iterate over a copy of SR of the S as an array. All right, let's just write it out. We'd have s dot length is greater than k. Then we'd like to break it up into groups of size k. Once you break it up into groups of size k, we'd like to sum those three values together and then add it to be our new s. We'd have our sum. So we'd break it up. Right. And so say if group size is less than 3, right? Otherwise, we're going to basically do the work right? We're gonna say sum plus equal parse int letter, right? Group size plus equals 1, and then if group size equals 3, right? I mean that's 3. If it equals k, right? We have to reset the group size, right? We also need to add it to the new s, so the new s is going to be equal to a string that we use concatenation for, I think, and then we'll place new s in, right, with, we'll place it in with the sum, right? So let's say sum dot to string, and I actually think this would duplicate new s multiple times. Actually, no, it wouldn't. It would bring it, if we had 1 for new sum and 3 for the sum, we'd say 1 and 3. Then we'd say, let's say we had 4 next, we'd say 1 and 3, put it here, and then put 4. And then we'll say group size equals and we'd also say sum is equal to 0. At the end of all that, we would say that s is equal to new s. This also doesn't account for when the group is if group size equals k, or index is equal to s dot r sub length minus 1. Okay, so this is wrong. It should have been what it was before. And this needs to be S. And then the whole SR thing can go. I don't understand why this is giving me so much trouble. Is S maybe it's like this, IDX. Oh no. If it's an array, then we have to say dot entries. And then we can switch them. So that handles when the group is less than k. And then we would need, I feel like we need one more thing. So we'll take that. This should be linear time, I think. Okay, linear time. Linear space, I guess. I don't really know how you would do this in place. So here we have projection area of 3D shapes. You're given an n by n grid where we place some 1 by 1 by 1 cubes that are axis aligned with x, y, and z axes. N by n grid where we place some 1 by 1 by 1 cubes that are axis aligned with the x, y, and z axes. So example 1, it looks like we have the cubes existing somewhere in the center. Their y being wait, this is so confusing. It says XXY. This must be Z. No, Z would say something about the height. This must be X. This must be Y. Must be Y. Each value v is equal to grid sub I sub j represents a tower we view the projection of these cubes onto the x, y, y, z, and z x. I have no idea what this question is asking. We're supposed to be calculating the total area, but at the same time, I don't understand what we're being shown either. We're going to try convert binary number in a linked list to integer. Given head, which is a reference node to a singly linked list, the value of each node in the linked list is either 0 or 1. The linked list holds the binary representation of a number. Return the decimal value of the number in the linked list. And can the linked list be empty? Okay, I think we can do this. If we do for let I is equal to 0, I is less than 32. I think everything is 32 bits. I think the number is 32 bits max in JavaScript. Number of nodes will not exceed 30. And do I++, and then we'll have access to head, and then we'll have access to num. Can return num. So we're going through forward wise. Actually, we don't even need to do that. We can probably just go straight through. And then what we'll do is we'll just OR the values into the number. So while head, we'll say num is equal to num bitwise OR power we'll say 2 to the power times head dot val, and then head is equal to head dot next. Maybe this isn't bitwise OR. I think it is though. Oh my god, I forgot to do power plus equal 1. Oh, we're starting from the bits are starting from the we're starting from the most significant bit, which means our power would have to start from the high end too. I wanted to find a way to do this in one pass, but there's a bunch of ways you could do it without doing it in one pass. I keep forgetting. And then we would change this to minus equals. So if we go, okay, if we go through, want to have more than 30 nodes. Starting at 30, right? Right, this is incorrect. Oh, I guess we'll just... Actually, I see what's happening. We just need to know the highest to start at, so it actually be power plus equal 1. Then we go here, we can start subtracting. So you get 1, 2, 3. Oh, that's true. We could have just added the numbers. That's also true. This is a cool one too, because I knew we could bit shift, but I thought the answer would be okay, wait, never mind. This answer is kind of crazy, actually. Wait, never mind. This is crazy. I think I'm not looking close enough. This doesn't make any sense either. Num times 2 plus head dot next dot val. There's a biker going on a road trip. The road trip consists of n plus 1 points at different altitude. Biker starts his trip on point 0 with altitude equals 0. They are given an integer array gain of length n, where gain sub I is the net gain in altitude between points I and I plus 1. So the difference. Return the highest altitude of a point. I'm not really understanding the problem, but it looks like we could get it if we did something like max out is equal to gain sub 0. You can do for let I is equal to 1. I is less than gain. Then we say math. Say max alt plus gain sub I. I mean, we let max alt equal to negative infinity. And then we'd say alt plus equal gain sub I, and then we'd say math dot max of max alt or alt. Negative 10. I'm not following why this is not working. I see. Alright, it looks like we were on the right track, but I thought I was looking at the right test case, and it was right. I was looking at the wrong. Oh my god. I didn't even realize. Nums dot length minus 1 is what I meant to do. I'm thinking if we're looking for the biggest difference between the products, max product difference, then we can just sort the array, and presumably the bottom two would give you, bottom two multiply would give you the smallest number, and the top two multiply should give you the largest number. And I think that's where we'll stop for today.